Welcome to part 2 of lesson 4.2, writing the equation of a parabola. In the previous lesson, the vertex was at the origin. Now we're going to look at when the vertex is at a different point that we're going to call h comma k. You should be already familiar with our vertex form of a parabola. And in the previous lesson, you learned that coefficient a is equal to 1 over 4p, where p represents what we call the focal length. So if we substitute in 1 over 4p in for a, then we get a modified version of vertex form. This would be for a parabola here that opens up or down. And then we have the inverse, in which this opens left or right. I want to point out some differences with this second equation. Notice we do change the x and the y. So just like a regular inverse, we switch those places. But notice that with the y, the k, so that's the y coordinate of the vertex, stays with the y. So if you notice, you can think of it as these two have switched places as well. When we get to some problems that involve parabolas opening left and right, I'll point that out again. So our goal today is to be able to write the equation given some information. We might be given the vertex, you might be given the focus, you might be given the directrix. And using any of that information, we want to be able to write the equation. Our first example starts with the vertex, given the vertex, and given the focus. The first step you want to do is to sketch a graph. Now I could teach you several formulas that are in your textbook, things that you have to memorize, but you know everything you need to know once you know vertex form, and that you know a equals 1 over 4p, and everything else, if you just sketch a graph out, you can calculate it from the graph and not have to memorize some formulas. So start by applying the vertex. So the vertex is at 6, I'm going to say 6 is right here, 20. So let's say it's about right there. So I'm going to label that 6, 20. And then I'm going to plot my focus. So my focus is at 6, 11, which means it's farther down here. So 6, 11. Now, knowing what we know about parabolas, we know that the parabola is going to have to open down in order for the focus to be inside the parabola. You also know from the previous lesson that this distance, the distance between the vertex and the focus, so let me label that vertex and focus, that difference there is what we call p. So we can find out what p is. P is simply 20 minus 11. So p equals 9. Now notice that this opens down. In that case, we need to add a negative sign to p in order for the parabola to open down. So that's going to be p equals a negative 9. If the parabola opened upward, then we keep p being a positive 9. So now let's go to writing the equation. We just substitute everything in. Now since the parabola opens downward, we're going to use the first equation, in which we have y equals 1 over 4 times p. We said p was negative 9, quantity x minus h is the x coordinate of the vertex. In this case, that would be a minus 6 squared. Let me grab my pen here. Plus, and that would be the k would be the y coordinate of the vertex, which is 20. So since I can't see it on my screen, I'm going to write it up here. The vertex was at 6, 20. And this is what we call h, k. Let's simplify and we'll have our equation. Y equals negative 1 over 36, parentheses x minus 6, quantity squared, plus 20. And there is our equation. In our next example, we are given the vertex again, but this time we're given the directrix. So start by sketching the graph. So the vertex is at, let's go 1, 2, 3, so at negative 3, 6. So I'm going to say it's about right there. So I'm going to label that as negative 3, comma 6. My directrix is x equals negative 1.75, which is about right here. And since it's x equals, that means it is a vertical line going through x equals negative 1.25. Now we know that the parabola never goes through the directrix. So in this case, that means our parabola is going to have to open to the left. Our value for p can be found from this distance from the directrix to the vertex. So that would be the difference of, we have negative 3 and we have negative 1.75. So our p is going to be the difference between those two. So the difference between them is 1.25. So I'll add 1.25. Now because this opens to the left, that means we need a negative p-value. So I'm going to add that negative inside. So let's move over with this information now and write our equation. With the parabola opening to the left, I'm going to use the second equation here. So let's go ahead and substitute in. Let me write down my vertex before I forget. The vertex on this problem was at negative 3, comma 6. And we see it said our p-value was a negative 1.25. I'm going to change that to a fraction just so it makes my math a little bit easier when I substitute in. So let's go ahead and substitute in. We get x equals 1 over 4 times negative 5 over 4, parenthesis, y minus k. Now keep in mind, this is h, that is k. So this is going to be minus 6 quantity squared plus h. So I'm adding a negative 3. Let's go ahead and simplify. X equals, well here I can simplify 4 divided by 4 is 1. So that gives me a coefficient of negative 1 over 5. Y minus 6 quantity squared minus 3. And there is my equation for the parabola. Now with a graphing calculator, you can always check this equation, graph this equation, and see if it looks similar to your sketch. The next example, we are given the focus and the directrix, so not the vertex. But we're going to sketch the graph out first. So our focus is at 5, comma 3, so let's say that's about right there. I'm going to label that as 5, comma 3, and I'm going to call that the focus. And then the directrix is y equals 7, so that means it's a horizontal line up here at 7. So I'm going to call that y equals 7. Well, as you know, the parabola, or the vertex, is halfway between the focus and the directrix. So the vertex is somewhere right here between those two, which means our parabola has to be opening downward. So we need to know this distance from here to here or from here to here. Both are a measurement of p. Well, the easiest way to do that is get the total distance between these two and divide it by 2. So it's just half that distance. So we take 7 minus 3, which gives us 4. So that's a total of 4 units. Divide it by 2, and it means our p-value is equal to 2. So let me show you how that works. So if I add 2 to 3, that's going to get me up here at 5.5. If I add 2 more, that's going to get me up to 5.7. So that is an equal distance of 2 both ways. Now this parabola is opening down, so that means we've got to add a negative in front of our p-value. To write the equation, we also need the vertex. So the vertex, the first coordinate is 5, because it would be on the same axis of symmetry as the focus. And it's 2 units above the 3, so that would make the vertex at 5, 5. That's all the information we need to write our equation. So I'm going to move over here to the right. Let's substitute in. This parabola is opening down, so I'm going to use the formula y equals 1 over 4p x minus h quantity squared plus k. Let's substitute in. We said that p was a negative 2, x minus, so my vertex, here's the h, here's the k, so my vertex is at 5, 5, so that would be x minus 5 quantity squared plus 5. Let's simplify. I'm going to bring that negative out front, so it's negative 1 over 8 x minus 5 quantity squared plus 5. And there is our equation. All right, one last example. In this example, you're given the equation for the parabola, only we want to convert the equation to vertex form. So start by grouping all the y's on one side and all the x's on the other side. So I'm going to put y squared minus 6y on the left side. I'm going to leave some space there because we're eventually going to complete the square. I'm going to move this negative 20x over, so that's going to become a positive 20x. And I'm also going to move this negative 51 over to the right side, so that becomes plus 51. All right, let's complete the square. So if I take the negative 6, divide it by 2, and square it, that gives me plus 9. And since I added it to the left side, I'm going to go ahead and add it to the right side as well. Now let's factor the left side. We get the quantity y minus 3 squared equals 20x plus 60. So I can just go ahead and add these two together and get 60. Well, we're almost there, but not quite. The left side, we have our quantity squared. But what we need to do is on the right side, I want to get rid of this coefficient here. So I'm going to factor out that coefficient of 20, which leaves me x plus 3 in parentheses. Now divide both terms by 20, which is the same thing as multiplying by 1 over 20. So that gives me 1 over 20, y minus 3, quantity squared, equals x plus 3. Now we're almost there. I want to subtract 3 from both sides, so that gives me the equation 1 over 20 y minus 3 squared. Subtract 3, so I'm going to put that 3 on the outside at the end, equals x. I'm going to move my screen down, and I want to write the original formula where we had 1 over 4p. And if you recognize right here, since we have x equals, this is that inverse. So this is a parabola that's opening to the right. So it's y minus k quantity squared plus h equals x. So remember that when the parabola opens left or right, okay, these switch places as well as the x and the y. So this is our equation. Our vertex, remember, is h comma k. So in this case, the vertex is going to be h, which is negative 3, and k, which is a 3.